Aloha, guys. This is Dr. Tom coming at you. I'm on the road traveling, but it won't stop us from our fascinating discussion. And today it's going to be about the urinary system. So here we go. Organs of excretion are the kidneys, the sweat glands, the lungs, the intestines, and of course the kidneys. Okay, in the urinary system we have two kidneys. We have two tubes that lead from the kidney down to the urinary bladder, which are called ureters. We have one urinary bladder, and we have one urethra. The urethra is the tube that leads the urine outside of the body. To be technical, we have to call it the urinary bladder because there's another bladder in the body. What is it? Who can tell me? I'm waiting. Of course, the gallbladder. The gallbladder. Okay, the regions, let's see, the renal cortex, renal columns, renal medulla, renal pyramids, renal pelvis. Okay, there's a capsule around each kidney. Here's the cortex, here's the medulla, like we've commonly seen, for example, in the adrenal glands, which happen to be on top of the kidney. Blood supply, well, there's a renal artery coming off the abdominal aorta and a renal vein that returns back up to the inferior vena cava. Functions: regulates blood volume and electrolytes, big time important. Regulates acid-base balance. We all know how important that is now. Excretes nitrogenous waste. Guys, proteins are characterized by having nitrogen, and nitrogenous waste begin to build up in the body from the degradation and metabolizing of proteins. So the kidney is charged with getting rid of those. Helps regulate blood pressure. Regulates RBC production. Remember, it secretes hormones that stimulate the production of red blood cells. Urine making. Okay, the functional unit, guys, of the kidney is called the nephron. And here's what it is. A nephron is a complex capillary bed called the glomerulus. You'll need to know that. And around the glomerulus is a capsule called Bowman's capsule. So what is a nephron? It's the glomerulus with Bowman's capsule. Also, too, there's a complicated tubular system that comes out of each nephron. And there's an extensive vascular network, capillary network, as you can see here. So what happens, guys? Blood comes into the kidney. It's filtered through Bowman's capsule and the glomerulus, and then what's filtered goes through this tubular system, and then the kidney has this extraordinary ability to go in there and choose what to return to the blood in the capillary beds or what to let go out the body as a waste product in urine. And that's what takes place here. Function unit composed two parts: renal tubules, renal blood vessels. So the way they're doing it here, the nephron includes glomerulus, Bowman's capsule, and the tubular system as well. I forget how many is in each. I should have looked that up. Each kidney, but I'm sure it's an enormous amount. I'm thinking 1 million, something like that. Renal tubules, glomerular capsule, or Bowman's capsule. I've always heard it called Bowman's capsule. There's a proximal convoluted tubule. Proximal means closer. There's what's called a loop of Henle, and there's a descending and an ascending loop. And then the distal convoluted tubule, and then finally the collecting ducts. And the collecting ducts, guys, are these various, from these various nephrons, all in the kidney, all joined together and gather the urine, and it's eventually excreted out of the kidneys. This is extraordinarily complex, but, you know, we could say that about anything in the human body. Just another absolutely amazing thing here. Nephron unit blood vessel. Well, there's a renal artery, branches off the abdominal aorta. An afferent arteriole goes into the glomerulus. After it goes through the glomerulus, it's efferent arteriole, and it becomes what's known as peritubular capillaries. Now, guys, this is a little simple drawing, but this stuff is complex beyond belief. Right here we can see is where they took this little section from. And then eventually the peritubular capillaries become little venules and become the renal vein. Throughout the tubular system, wanted items are absorbed back in and added back into the blood, and items that need to be gotten rid of remain in the tubular system and eventually become urine. 3 steps in urine formation, okay? First is glomerular filtration, okay? Filtrates to the glomerulus. The second is tubular reabsorption. They're showing most of that taking place in the proximal convoluted tubule into the peritubular capillary right here. And then there's tubular, but it also can occur down through here too, guys. And then tubular secretion is it ends up staying in the tubular system and going into the collecting duct. Now remember, aldosterone from the adrenal gland helps conserve sodium and electrolytes. That works here at the distal convoluted tubule. And a diuretic hormone from the posterior pituitary helps reabsorb water. Otherwise, you'll have enormous amounts of water being urinated out. So, yes, it's quite amazing. Glomerular filtration, water and dissolved solute. Solute's the stuff dissolved in a solvent. Water is the solvent. Filter across glomeruli into Bowman's capsule. Why it occurs? It occurs when the pressure on one side of the membrane is greater than the pressure on the opposite. Now we see, guys, why the kidneys play a role in determining blood pressure. They have to have a certain pressure. What substances are filtered? Water, sodium, potassium, chloride, glucose, uric acid pass through easily. Large blood cells and large proteins cannot fit through the pores. Normal urine, guys, should have no proteins, no sugar, and no or few red blood cells in it. If it's diseased or damaged, then it'll let these things through. Or if you're a diabetic and you have too much blood sugar, at a certain point, 160 milligrams per deciliter, it'll start appearing in the urine. Okay, the rate with which the kidney dissolves all this stuff is called the glomerular filtration rate. The rate, or GFR, the rate at which water and solute are filtered. Blood pressure determines it. Again, the importance of blood pressure, why the kidney is able to regulate its own blood, or not its own, but the blood pressure. Normal glomerular filtration rate is 180 liters of water in 24 hours, or 125 milliliters of water a minute. Tubular reabsorption returns the filtrate from the tubules to the blood of the peritubular capillaries, okay? Most reabsorption takes place in the proximal convoluted tubule, which we said a moment ago. The kidney chooses the type and quantity of substances it reabsorbs. There's a consciousness almost at work, guys, but of course Dr. Tom is a student of such things, and I think that everything is conscious. Okay, urine formation, tubular reabsorption. What's reabsorbed? Look, almost all the sodium, aldosterone, plays a big role in that. Almost all the water. 100% of the glucose unless it's too high. Urea, which is one of the byproducts of nitrogenous waste. Creatinine, 0. Let's see. Okay. Why is no creatinine reabsorbed? Because we want to get rid of it all. It's a waste product. So look how amazingly effective this is, guys. Okay, mechanisms for tubular reabsorption. For example, sodium pumped into the tubule into the peritubular capillary. Passive examples are water, chloride chloride passively follows sodium into the peritubular capillary. Water and other solutes, guys, will often follow sodium because nature wants to have that equilibrium, that balance. Tubular secretion moves very small amounts of select substances from the peritubular capillaries into the tubules. Of course, these are things that they're wanting to get rid of. Potassium ions, hydrogen ions to lower the pH, or raise the pH, I'm sorry, as you were. Uric acid, ammonium ions, drugs. Aldosterone, remember from the cortex of the adrenal cortex. Works on the distal tubule and upper collecting duct of the nephron unit, right in here, right towards the end of it. It's the salt-retaining hormone. That's a good way to remember it. Effects increases salt water reabsorption. Water will follow salt, of course. Increases blood volume and increases blood pressure. Okay, now there's another mechanism in the kidney called the renin angiotensin. Renin is released from the kidney when there's low blood pressure. Again, the kidney has a vital stake, guys, in maintaining blood pressure. Why? Because blood pressure is what determines the glomerular filtration rate. So angiotensinogen secreted by the liver and circulates in its inactive form, which that is the inactive form. Then it's turned into angiotensin 1. The lungs release the converting enzyme. It's amazing. Then in turn, it's turned into angiotensin 2. Potent vasopressor regulates blood pressure, blood volume. And then aldosterone is released by the adrenal cortex. Distal tubule, kidney reabsorbs sodium and water and excretes potassium ion. The renin-angiotensin aldosterone system, most important stimuli for the release of aldosterone is renin. Renin is an enzyme that activates the renin-angiotensin aldosterone system. Series of events: renin released from the kidneys because of low BP. We said that a moment ago. Then angiotensinogen is the inactive form. Angiotensin 1 is converted by an enzyme coming from the lungs. See how complicated all this, guys. Angiotensin 2, and then aldosterone is released by the adrenal cortex. What does it do, guys? It maintains blood pressure, and so forth. Okay, ADH, you might recall, is one of the two hormones produced and secreted by the posterior pituitary. It's also called vasopressin, but more commonly it's called ADH. Released by the posterior pituitary in response to low blood volume or high concentration. Water moves out of collecting duct into tubular tissue spaces and then into peritubular capillaries. ADH decreases the excretion of water and causes excretion of concentrated urine. It manages and holds onto water, guys. Otherwise, if you don't, you have the disease diabetes insipidus and you urinate out large amounts of water. Let's see where you said that. In response to low blood volume or high concentration, ADH decreases excretion of water. ADH is crucial in the determination of blood volume and blood pressure. Water moves out of the collecting duct into the tissue spaces and then into the peritubular capillaries to be conserved and not released. ADH excess, blood volume expansion. ADH deficiency, very dilute urine. Again, diabetes insipidus is the disease. Look, ADH is aldosterone. Now remember, the stuff is moving this way, guys, like this. Now, just like the arrow show. Excuse me, my voice is bothering me a little bit. Aldosterone from the adrenal cortex works here right at the distal convoluted tubule and the collecting duct, and ADH even further. Excuse me, I'm traveling and I've got a little bit of a cough. Characteristic of urine. Average 1,500 milliliters in 24 hours. Oliguria is if you're not producing enough. We have to cut this short. We're about out of time anyway. Polyuria is when you're producing too much. Let's see. pH. Blood pH is in a very narrow range. Yes, but urinary pH can the average is about 6, but it can run from 5 to 8. Specific gravity, we haven't talked about that, I don't think. We'll talk about it soon. It's the amount of solute dissolved in a solution. Specific gravity of urine is 1.001 to 1.035. Means it's almost all water, but there's a little bit in it. Color of urine is important. Amber or straw color, deep yellow is dehydration, real pale yellow is it's too watery. Okay, we're going to stop here, guys, and continue in our next one. We're just about out of time. I'm recording this under different circumstances and on a different computer. Excuse me for not having something to hose my dry throat with, but I didn't, because I'm just testing this. All right, this is Dr. Tom signing off. Catch you next time, guys.